So you think the sun is big? That's actually adorable. Now, I'm not gonna do the thing where someone compares the sun to a basketball and Earth becomes a grain of sand. We've all seen that graphic and it stopped being impressive sometime around 2010. Instead, let me introduce you to something that makes the sun look like a birthday candle someone forgot to blow out. Meet the quasi-star, possibly the biggest star the universe ever built. I say star because technically it wasn't.
This is where the fun begins.
Imagine taking a black hole, wrapping it inside something millions of times heavier than our sun, and somehow calling that a star. Yeah, the early universe was experimenting. Now, before we continue, you're gonna hear words like may, possibly, could, a lot today, because we're entering the realm of theoretical astrophysics, where the equations work, but the Big Bang wasn't exactly live-streamed, you know. A regular star, the sun, Betelgeuse, wherever your favorite is, runs on nuclear fusion, hydrogen atoms smashing into each other at the core, releasing energy. That energy pushes outward against gravity, gravity pulls back in, and the star just vibes in the middle of that argument forever. It's a whole standoff, a constant negotiation, very diplomatic, very stable. A quasi-star looked at that arrangement and skipped the meeting entirely. To understand why quasi-stars may have existed, we need to go back almost 13.5 billion years. Back when the universe was basically running the free trial version. No rocky planets, no oxygen, no dinosaurs, just hydrogen, helium, and a whole lot of darkness. Here's why that matters. Today's universe actually knows how to make normal stars. The early universe didn't. Modern gas clouds contain heavier elements, like metals, that help gas cool down. Cool gas breaks apart, forming thousands of ordinary stars. But back then, those elements didn't exist yet. So some of these clouds collapsed so fast and so violently that they skipped the whole fusion process entirely, and went straight to forming a black hole before the star could even get its bearings. And instead of the black hole immediately destroying everything around it, the surrounding gas was so insanely massive that it held itself together. The pressure from the black hole consuming material released just enough energy to keep the outer layers inflated. Now here's where physics gets weird. Normally black holes are terrible at overheating. As gas falls toward them, it gets so hot that radiation blasts outward, pushing the remaining gas away. It's called the Eddington limit. Basically, physics looking at the black hole and saying, slow down before you choke. But inside a quasi-star, that limit gets completely hacked. The radiation can't escape directly into space. It has to fight through an envelope containing hundreds of thousands, maybe even millions of solar masses. Imagine trying to leave a sold-out concert where every single person weighed as much as Jupiter. You're not going anywhere. The radiation gets trapped, the giant envelope absorbs it, which means the black hole can keep eating far faster than it ever could on its own. So instead of taking billions of years to grow, it may have reached 10,000, 50,000, even 100,000 times the mass of the sun in a cosmic blink of an eye. So cosmically speaking, that's speedrunning. And that's exactly why astronomers care, because telescopes keep finding supermassive black holes less than 800 million years after the Big Bang. Some already weighed billions of suns. That's like walking into a kindergarten and finding someone who already retired with a pension. There simply wasn't enough time, unless they cheated. Quasi-stars may have produced gigantic seed black holes that already had an enormous head start. Instead of climbing the ladder, they spawned halfway up it. Eventually, the parasite becomes larger than the host. The black hole kept consuming more and more of the surrounding gas until the giant envelope could no longer support itself. The quasi-star disappeared, leaving behind a massive black hole already far larger than anything an ordinary star could produce. From there, gravity handled the rest. It kept feeding, kept merging, kept growing, eventually becoming the supermassive monster sitting at the center of a galaxy. Who knows, maybe even our own. But here's the catch, we've never actually seen a quasi-star, not even one. Everything you've heard today comes from physics, computer simulations, and our attempt to explain observations that otherwise don't make much sense.
I hate to say it, but it looks like the system you're searching for doesn't exist.
Impossible. Perhaps the archives are incomplete.
So yeah, quasi-stars may have existed, they could have existed, they possibly existed. See, I told you those words were coming. But every time astronomers discover another impossibly ancient supermassive black hole, the quasi-star idea becomes a little harder to ignore. Do you believe quasi-stars existed? Tell me in the comments below. Remember when I said the sun looked like a birthday candle? Turns out it wasn't the candle. It was never even the biggest fire in the room. Because somewhere near the beginning of time, the universe may have built stars that weren't really stars, just to grow black holes big enough to build galaxies. Space doesn't always follow the rules. Sometimes it writes new ones. Thank you for watching. Don't forget to subscribe and share your thoughts down below.